My name is Meghan. I'm one of the officers that will be presenting this tonight. It's going to cover multiple disciplines. Up on the roster, we're going to talk about general project management, programming, 2D art, and 3D art. Well, good things you should do when developing games. To start, we're going to talk about good general project management because that's always very important and it's good to be organized. To start, good project management, there's a lot of tools to help you with project management. Those are supposed to have hyperlinks, but they don't seem to be showing that right now, but it's fine. So some tools that really good websites that you can use to keep either yourself organized or keep your group organized is Trello is good for having projects in little, like having a whole overarching column and then small little tasks or due dates or cards as they're called to give a description of what the specific section is supposed to be and then when that should ideally be due. So you could have an art column and then a card for each individual asset that you need to make, and then a general description and updated timeline of new versions, comments, or a due date for each of those assets. It's just one example. And then Miro is an online collaborative whiteboard service that I've been told about, and it's pretty neat. And like you can see everybody moving, everybody's cursors moving. You can just drop little sticky notes everywhere. It's a very good tool for kind of like more of a whiteboard type of an ideal. And you can also organize information such as you have outside references or literally anything that you need to pin together. It's just you just have like the whole big old wall of sticky notes and string going everywhere. It was what that's really good for. And then so both of these tools are useful for trying to keep track of your project, but then also dealing with your scope. Scope is a very difficult thing to manage when you're making a game, and games are very complex. So when you're making your first game, it's good to have an idea to kind of keep it small. Like I think the iteration that we use is what would you make in a week if you had an entire week, a 40-hour week to make it, and then you kind of stay in that general line for like a whole semester, because honestly that's all the time you're going to probably get to work on your own personal project unless you have, can put time aside for it. So try to keep your scope in check. It could be, even if you don't have a full game idea, you can work on managing one mechanic. You can work on managing a series of environments or a series of characters or building upon a mechanic. You can do micro games, which is what Unity calls them. They're very small things. So it's good to be able to divide up your larger ideas, future ideas, and the smallest stuff that you can take bites out of as you're learning how to make games, because it's really disheartening to kind of overload yourself and look at everything at the same time and be like, I don't know how to do anything. And then you just don't work on anything. So you want to kind of keep it manageable for yourself. And in that respect, don't be afraid to ask for help, especially in the dev help channel. That's why we have it. If you don't know specific code analogy or you need somebody to critique your art, you can post it there and be like, I need some help. I don't know what I'm doing. And that's okay. Professionals do that all the time as well. So don't be afraid to not ask for help, especially as a student. So continuing on, also guys, feel free to ask questions throughout the presentation, or at least somebody tell me, because we can end specific topics, because we can answer them as we go throughout, or you can ask them at the end if you'd like. So continuing on, we're going to move into the good programming practices, and that I think is led by Joseph.
Yeah, so the way we're going to do the good programming practices is it's not going to be a presentation. It's I've made a couple scripts for you guys. And we're going to do a live demonstration of editing the scripts to kind of follow good programming practices, or at least the practices that I've learned over the years. I would like to preface this with, I am not an expert. I've learned some things. They're not necessarily the best things, but they're pretty darn good, I would say. So if you know of an even better way, I would encourage you to let the club know over Discord. Because I am always learning new things, and it's always exciting. So I'm going to start this with sharing screen 1. Cool. So if we look, first of all, I'm going to ask, does everyone have access to the Discord? And then I need to be able to see chat, so let me pull up the chat. Well, the chat won't pull up for me. All right, I'm going to assume by the fact that there's no messages in the chat that everyone has access to the Discord. So in Discord, there is a Unity package that I've put in the general talking channel. If you download that and you put it into a Unity project, whether it be a new Unity project or yeah, to put it in a new Unity project probably, you'll get, I think it's 4 scripts and a material. I'm gonna let people have time to do that because there we go. We're gonna edit those scripts right here. Over here, move that over here. I'm gonna give it like 2 minutes for you guys to like set up a Unity project, and then hopefully get all that stuff in there. Is there anyone who's having trouble with this? Let me know and I can assist. I don't like waiting. I don't like silence.
You know, me and Mitchell are rapidly trying to fix up these slides ahead of you.
That's really exciting.
Mitchell, what you just did here? Oh, never mind.
The semester is hitting hard.
Yeah, it's like trying to build the tracks in front of the train that's like moving forward.
Yeah. It's fun. It's fun.
There's a game I've seen that does exactly that, and I can't remember what it's called off the top of my head.
I know what you're talking about. I know what you're talking about.
Yeah.
I can find it.
Literally I just saw it within the last week.
It's like called Track.
It can't be that simple.
I know it's like a really short title.
Josh in the chat's Unrailed.
Yeah. Yeah, Unrailed. Okay, there you go. It is just like the one word. Thank you, Josh.
Cool. So
is
there anyone that doesn't have the scripts and material imported into their project yet? I give like 10 seconds. Post in the chat if you don't got it. Cool. So the way these scripts work, we have a character script, a character fixed script, a gun, and a gun fixed script. The ones that are not prefix, but whatever the word is for after prefix, with fixed, they are the scripts that are good practices, or at least as I've learned them. The ones that aren't like that are the ones that are bad practices and kind of hurt me to make. So if you can put in just a 3D after prefix, if you just put into a cube into your scene, and then you attach the gun script to it, and then if you put another cube into the scene and you attach the character script to it, we can watch how the bad code works. I'm going to delete those for now. Name the cube's gun and character as well, because that's actually important, which is part of the bad practices. A couple seconds. So then when you press play, and if you were to press spacebar and you're looking at the character, you'll see that the health of the character goes down every time I click or every time I press spacebar, which is cool. But then you look into the code. And so now we are going to pull up, if I can find the correct ones, there we go, the character and the gun scripts. So looking at gun, it's just this one thing that happens on update. It checks if the space key was pressed. Then it finds a game object called character. It gets its component of character and it changes the health. I'm gonna make this an open question. Why is this a bad line of code? Feel free to unmute and just hit me with it.
It doesn't check to see if there's anything it's actually having any collision with. It just immediately assumes, oh, anything named character is what this gun will be hitting. So if there's nothing named character, it hits nothing. And if anything is named character, it's immediately hit.
That's a good
Not
point.
to mention, it'll only return one of the many character objects there might be, and that one is an arbitrary one from the list.
That is also true. I should probably have prefaced
And there's
this
also
with,
no bounds or anything to the health.
That's a good point. I want to preface this with, this is a very simple gun script. We're not trying to do collision detection. It's just kind of supposed to be, we are attacking one character. I didn't want to go through like the whole like ray casting and stuff because that's not what the thing is about. Let's see. Josh says it needs more variables, which yes, the 10 here is not a variable. It's a hard-coded number. It's a magic number, which is not good development practices because if you ever want to change the damage that the gun deals, you need to physically change the code, and that's not good. And Josh also said I hurt script, which is also a good idea. You don't want this to all just happen in the gun script. You want this to kind of be extracted and done in other methods. Lucas, thank you. Finding a player and getting its component is pretty intensive. That's exactly that. GameObject.find is something I loathe. I've seen this in quite a few projects. I've seen this in my senior project right now because we got the project from a last semester group, and it hurts. It physically hurts me because it's intensive and also it's reliant on this being the exact name, which is kind of oof. You don't want to have to rely on a game object being called a certain name. That's kind of iffy. And so we're going to change this. We're going to make this much, much prettier. And we can start with the magic numbers that we've got right here. So instead of doing just 10 there, let's make this damage, right? And so what we'll want to do is we'll want to make a public int damage variable, and we can instantiate that to 10 just for the beginnings. And this has the benefit of now we can just change the variable, as well as because it's a public variable going into gun, we can change it in the editor. We can make it go up, we can make it go down, all in here, and not have to worry about changing code. The way I recommend approaching systems is by saying, can I make a system that someone who doesn't know how to code can still use? And by putting public variables in there and allowing people to, designers to change the values in the inspector, that is a good idea. And then after that, we're going to get rid of the GameObject.find, and we're going to replace it with a public character model, and we can just name that character. And so this variable will be a reference to the character that we want to attack. So that way we don't have to do that anymore. We can instead do, actually, we won't even need to get component. We can just straight up do character. So now character.health will take damage. And then all you have to do here is make sure you attach the character to here, so you have a reference to it. So we're already in a pretty good space. We've gotten rid of the magic numbers. We've gotten rid of the intensive operation that was reliant on name. But now let's get a little bit more fancy. This character script doesn't really do anything. All it does is it holds the health of the character. We want some more stuff in there. We don't want it to just have the health. We should let the character do things. And so we are going to let the damage happen in the character script. So if you make public void damage, and then it passes an int argument, you can then let the character take damage through this method here. So instead it would be health minus equals hit. And so what this will do is this will subtract this many hit points from the health of the character. And so instead of doing this here, we do character dot damage. You're now passing along the damage operation to the character script. And what the biggest benefit of this is that it allows your code to be more developer friendly. As a developer, if I was given the stuff that was here before, I would have to completely rewrite it if I wanted to do multiple things. If I wanted the character to change textures while it gets hit, if I wanted to add particle effects, if I wanted to add sounds, I would have had to completely redo that in order to add more features to it. Now that things are a bit more abstracted, you can then do things like add particles. I can add things when this damage method is called. However, this still isn't quite that good. If we go back here, I'm going to make this thing disappear because I don't like that. We look at character and we keep shooting. You'll notice it still goes down into the negative numbers. It's not working quite right. So you want to do a couple more things to make it better. You would do a check if the health minus hit is less than or equal to 0. Set the health equal to 0. Else you can then drag that in there. Yeah, we're gonna go over the next parts later. So now what this will do is this will check if the health will get to 0 or lower, set the health to 0 if that's the case. But if it doesn't, then we just take damage like normal. And what this allows us to do is, one, you don't have to worry about your health getting into negative numbers, because I've seen this happen with the AR tower defense game that me, Will, Udayan, and Mitchell worked on over winter break, where when the health would get to negative numbers, the health bar UI would then like go in the opposite direction and we get overflows. So this prevents any weird negative health glitches that might happen. So it's good to always be careful of your bounds and set them with that. Let's see. And what this also does is if you want a death animation to happen, you can now have the death animation happen here. Whereas if you want just a normal hit animation to happen, you would have the hit animation happen here. You can be more flexible with where you're going to put in things in the future. It's kind of like thinking ahead. Let's see. Yeah, and then we can go over that real quick. So another thing that we would want maybe is for the material to change. So if you make a public material damage mat variable and a private material original mat variable, these will be the materials that the character will change to when it gets hit. And so I am honestly just going to copy code from character fixed at this point. And I'm just going to paste it in there. And I'm going to copy this here. And I'm going to paste it in there. And you all should have character fixed. So if you want to just copy and paste, that's totally fine with me. And then we'll talk about that in just a second. So now what all this will do is this will allow, this demonstrates how you can add more features to it since we designed it to be a little bit more developer friendly. What this will do is this will allow the character to turn a different material when it gets hit. And then the coroutine, which is something that kind of like runs parallel to everything else in the game and allows you to like do things like time delays, will change it back to its original material. And then what you see right here in the start method is that we set the original material when the game begins. This is just a really easy way for us to store the data that we had when we started the game, as opposed to making a separate reference to it. Because if we did a public variable here instead of private, we would need to set it in the inspector. And that's kind of like more overhead that we want to do. This limits that. Let me see. And so then if we then go into the dev practices scene and we look at this and we drag the damage material over here, what should happen is when we click, it will now take damage and it will change red whenever we do that. Let me see what happens when we go like that. Yeah, and now we don't get any overflows into negative numbers. All right. Also, is there anything in the chat? Because I have lost the chat and I can't see anything.
I don't think there's anything, yeah.
Chat's clear, cool. So now we're gonna get into attributes, which are insanely helpful. So attributes are little things that we can add to the code to kind of like make everything a bit more fancy. If we look in the scene and in the inspector, you'll notice that you can see health and damage material, but let's say we started adding a ton of variables here. It's going to get super long. It's going to look super disgusting. And someone who doesn't really know what the system does might not know what some of the variables that you put in there do, especially if they're not named very obviously. So attributes are a way to kind of spice up the inspector, so that way it's easier for people to understand what's going on. And so one of the attributes that we can do is tooltip. And if you do this, so health of character. So what we're doing right here is we're making brackets. We're writing tooltip, we're doing parentheses, and then just what we want to appear when you will hover over the variable. So when you hover over health in the inspector, a little window will pop up saying health of character. So this is essentially comments for the Unity editor itself. And this should happen once I click character and go right there. You'll see right there, it says health of character. Another thing that we can do is do header. And let's just do character properties. Then we look over here. You'll see this little bolded section will pop up, character properties. You can use this to kind of like separate your variables a little bit more. And so when someone looks at it, they're like, okay, this is what these properties are for. This is what these properties are for. Maybe some of them are supposed to be like prefab references, where you would just drag in a prefab for it to spawn or do something with. And it allows someone who doesn't know the system to fully understand what's going on. Or even yourself, if after like 6 months of not working on something, you go back to it and you're like, what the heck did I do? Which I admittedly have done many times. So that's what tooltip and header is good for. Another really good one is require component. So you'll see in the start method over here, we do GameObject.getComponent mesh renderer. So this is a little dangerous because let's say that the character didn't have this mesh renderer component. Can I actually remove it? Yeah, I can. Okay, don't do this, but we're just going to see what happens. On start, there's going to be an error, missing component exception, and then this will break your code. We don't want that. So we're going to throw in an attribute in here so that way it requires a component. So if you do all the way at the top of the script, require component type of basically gets like the class of whatever you're about to put in there. So mesh renderer, so this gets the type mesh renderer, and it says we are requiring that component if this script is in an object. So now what will happen, if I go over here, clear that, I go over here, and then I try to remove mesh renderer, can't remove mesh renderer because the character depends on it. And I think even if I create a new object without a mesh renderer, and then I throw in a character, it adds a mesh renderer for me. This is a very good way for you to make sure if a script relies on something, that something will be there when you call it. Otherwise, what you would have to do is you would have to do something like if game object dot get component mesh renderer does not equal null. And there's an error there because I did not put in the parentheses. You would have to do that, because what would happen is if we didn't have require component and we tried calling this when we didn't have a mesh renderer in the object, it will throw an error and the script will stop working, and that will cause problems later on in the game. And the number of times that a component not existing has caused problems for me is quite a bit, honestly. So even I would recommend also just doing this whenever you're trying to like access another object. Like let's say we had to do like a find operation and we looked for an object and we were like, does it have this component? Do the if statement, be safe. Because if you do this, then it will avoid any errors that might occur. And I'm gonna put that right back. So I think that's that for that. Oh, that's another. So another attribute I really like is min and max. So we'll use min right now because this is a gun. So the gun, you don't really want to do negative damage unless you want it to be a healing gun. So if you put the min attribute right above the damage variable in the code, and then we go over here and then we look at the gun and we're like, all right, I want the damage to be negative 500. Nope, it goes down to your minimum value. It'll be down at 0. And so you can do that with min and you can do it with max, and it essentially allows you to not have any accidental values that you don't want in your code. Let's see. Oh, shoot, that's another thing I wanted to do. So in the gun script, I forgot one more thing that I wanted to abstract. This is also kind of iffy because we're doing this in update once again. And if you wanted to add more, you'd have to add it into here, which is kind of a dirty place to do it. You don't really want to do it in update. So you would kind of abstract it into another method called shoot. And then put it like there, and then you could call shoot here. And so that way, if you wanted the gun to do anything other than just damage the enemy, you just add it to the shoot thing. So here you would do particle effects, you would do sounds, you put it all under shoot. And then let's see, let's go over this. So I am once again just going to copy and paste code because I don't want to type the whole thing out. This is the public enum gun type. Oh, that's being taken currently. So gun type 1. So what gun type will allow us to do is basically define things, hold on, have set properties for something and then define it as one of those properties. So if we added a public gun type 1 variable to here, and we named it type. And then we were to look at this, and then we were to go to gun. You'll see type, it has weak and strong available in the drop-down menu. So you can choose whether you want your gun to be weak or strong. And as of right now, that doesn't do anything because we don't have any code attached to this type. However, if we were to, once again, copy code from gun fixed and put it in shoot, which is what I'm gonna do. Gun type 1, gun type 1. You could then better define things such as if the gun is supposed to be a weak gun, it does normal damage. If the gun is supposed to be a strong gun, it does double damage. And all you would have to do as a designer, as someone who doesn't know how to code, is change whether you want the gun to be weak or strong. And so that way, someone who doesn't know how to code can have more flexibility over how the weapon should react. And then an example I kind of want to show is Armed Forces, which is a game I'm currently working on for my games projects class, where, I don't have enums in this, do I? No, I don't. Okay, well, I'll still show this regardless. I go a little bit crazy with the attributes and stuff for these things right here. I'm pretty sure I have like minimums on everything. Yeah, we're just gonna assume that's 0. And I just add the headers and whatnot. And it just kind of looks nice, and it works pretty darn well, I would say. We're not going into that. We are not going into that. So let's see. Okay, now I see the chat. I'm gonna look at this for a second. Lucas, I actually don't know anything about caching. If you want to tell me about that, I think that would actually be really helpful for everyone to hear. If Lucas is here, I currently do not see the participants tab. Cool. So yeah, my throat's getting really dry. So I kind of want to take a small break, if that's cool with everyone. Where was I going with this? So I wanted to point out something. I don't think we need to make anything right now. I just want to kind of like point out some things that are kind of good. With commenting. So you're always told, comment your code. Let other people know what you're working on. Make sure that you comment it so that way you understand what you're working on. But let me tell you something. Commenting code is really fun because it makes it really easy to figure out what you're doing. Because I know whenever I'm coding, I don't know what I'm doing. So if you comment it in a certain way, we're going to take this out right there. This is all in like the fixed script, so you can get a good example of what to do there. If you type in 3 slashes, boom, it pops up summary, and the parameter. So then if you put in something like damages the character in for the summary, when you roll over this, it says damages the character. And so if you ever call this somewhere else, like in the gun script, and you're like, oh, what does this damage script do? It damages the character. You don't even have to open up the other script. It's super nice. So whenever you do comments, try to comment it this way, at least in Unity, because it's very helpful. And like hit, putting something there is like number of hit points of damage. And whenever you roll over hit, once my mouse wants to work, it will say number of hit points of damage. It makes everything much better to understand. If you don't comment any other parts of your code, at least comment like these 3-line things, because it's just so helpful when you have like these giant code bases and you don't know how anything works. Going outside of that, we're gonna jump to game managers. So game managers are something that we never really cover during our workshops, but like when you're making a game, they're necessary. I don't think I've ever worked on a game that didn't have a game manager in some way, shape, or form. And game managers, I've pulled up the game manager for the AR tower defense game that a group was working on over Christmas break. And it basically stores all of the information about the game. So looking at this, this is just, actually, let me pull it up in Unity because it'll probably be easier to understand. It stores text boxes that we want to be changing while the game's going on. It has enums for things like game phases that are happening, references to objects like spawners. It's mostly references to objects within the scene. So that way you can always access those objects and always manipulate those objects. But sometimes it's things like gameplay features, like the amount of money that you have in the game, or the amount of rounds it takes to win the game, or the number of enemies that are going to be spawning. These are essentially just like global variables and methods that you always want to have on hand, so you put them in a game manager. And the beautiful thing about that is that if you do the game manager as something called a singleton is like a class that exists only as one instance. There's not multiple instances of it. Then you can access it from anywhere and you don't have to worry about referencing it. And so I'm going to show you how to make a singleton in Unity, because I never knew until like a couple months ago when Will showed me and my mind was blown. So I didn't have this in the package that I sent you guys because I forgot about it until I was literally giving this presentation. So this is what we've got here, and then you can copy it. I'll throw the script into the Discord. Heck, I can do that right now if you guys really want it. Once the thing decides to load, general talking, game manager, boom, boom. And then you can just import that. This game manager is pretty bare bones. It doesn't do all of the fancy stuff that I just said that a game manager should be doing. Instead, it's mostly just the singleton application of it, which is this right here in the middle. And then a simple function that can demonstrate how you can use the game manager from other classes. So what you'll want is you want a public static variable. You can call it instance. You want a public static method that returns instance. And then on awake, you do this nice little boilerplate code. If the instance is not null and the instance is not this, you destroy this instance of the game object. Otherwise, set the instance equal to this. And what this just does is it just makes it so that way there's only one game manager in the game at all times. So it's pretty good. It's pretty good. This public destroy all method right here can be accessed from any other script in the game. So we're gonna throw in gun. So when the gun shoots, what we want it to do right now is we want it to destroy both the gun and the character. We want it to be essentially a nuke. So we are going to do, if I can get this working correctly, because I never actually tried this yet. Game manager dot instance, I'm pretty sure is what you want to do with that. Dot destroy all, and I'm going to assume that works. You basically just call for the instance of the game manager, and then you call its public variable or public method destroy all to destroy all of the stuff in the game. And so destroy all is something that we created. So we need to make sure that there actually is a game manager in here. Normally what you do is you just create an empty game object that doesn't have anything inside of it. And then you just throw the game manager in there. And now we can reference the character and the gun in our game manager. And now when you shoot, boom, the gun and the character died because it called the destroy all method in the game manager. Don't usually do that, I would say. There shouldn't really be a need to do that, but this was just like a good way to kind of demonstrate how to reference a singleton game manager from anywhere within the scene. And I believe that covers everything I wanted to go over, besides scriptable objects. Great. This will be another thing that I kind of just point at, and I'm not going to give an example to. But if anyone wants to learn more and like delve more into this, I'm more than happy to explain it. So scriptable objects are essentially data containers. They should not do anything, I say, as I remove bad code that I had written a couple months ago. So this scriptable object that I made, a weapon, this is all for armed forces that I did. It contains the weapon name, the description, and a mesh and a material. This just holds stuff. And then what you would do is in another script, like ARM, you can have a reference to that weapon. So let's look at equipped weapon. This says, okay, we currently have one of these data containers stored in our code, and then you can mess around with it. I think if I click that, it should allow me to see things in here. We're just going to ignore that for right now. It basically allows you to use the data to do things with it. And so it's getting the weapons information. So like when we shoot it, holy crap, where did I put it? I'm not gonna go through my entire code because I just don't have the time for it. We can access the weapon name, the weapon description from any from whatever is containing it. I'm gonna get that back because that, oh, those are getters and setters. Haha, those are fine. Cool. And then another thing that I would like to go over is inheritance, which is, so we have this weapon scriptable object, right? If you want something that is a weapon, but is also its own thing, you can inherit it. So like normally what we have is a mono behavior, right? When we create a script, we end up having a mono behavior that the script inherits. And that just basically means it's a component that can be attached to an object. With weapon, it inherits scriptable object because it's more of a data container as opposed to a component. You don't throw a scriptable object onto a object. You throw it into like a reference. Then you can say something that's a bit more specific, like a semi-automatic weapon inherits weapon. So that way this scriptable object has all of the properties of this scriptable object as well. So there's weapon properties and then semi-automatic weapon properties. And I don't have that open anymore, so I can't really show it that well. But it allows you to kind of branch out. And so when we have a weapon, you can then have a semi-automatic weapon, you can have a launcher, you can have an automatic weapon, and they're all weapons, but they're also their own unique things. And if you are in, I believe 216 goes over this, this is all going to sound insanely familiar because that's what we learn. So you can always apply the stuff that you learn in classes to game development in these ways. And that is everything that was on my list. And now my throat is super dry and there are things in the chat. Okay. Does anyone have any questions? That was a lot of information I kind of went through near the end.
There was a question about how is there only one instance if Awake destroys itself in that process?
Because Awake destroys itself if there is another instance of it. It basically destroys the duplicate. Yeah, essentially what Alberto said in the chat. When it's initialized, it will create the single instance. Then any other instance will say, hey, this instance already exists, and self-destructs. I honestly don't know exactly how that works. I just know it does, and I kind of run with it. But cool.
One of those instances of don't think about it too hard. It's just fine.
Yeah, that's the way I treat programming. But cool, if there's no other questions, I think it's safe to move on with the presentation. The programming section's done.
I do want to mention that for the networking workshop, I will cover making a networked game manager.
Ooh.
So exciting, so exciting.
And then just another description for game manager is it's what handles the game loop of the game.
Okay. Anyway, thank you, Joseph, for that wonderful programming workshop. I'm gonna have to review it again so I can get my coding basics, but I appreciated it. So now we're going to move on to good 2D art practices. I'll be talking about this one mostly. To start, you have to optimize your resolutions, and nobody really ever mentions this. And I learned this at a game jam like 6 months ago. But most art assets work in powers of 2. And I think that's common knowledge. I think maybe if you're modeling, but nobody ever tells the 2D artists this, frankly. So if you're gonna make art assets, make it in powers of 2. All your character sprites, your UI will be that way. Well, the little icons specifically for the UI, any tile sets and any textures you use for 3D models will also be in powers of 2. So it's just kind of like a standard workflow. I think Unreal's a little weird, maybe on certain aspects, but for the most part, it's standard procedure to use powers of 2. So it's good to get in the habit of using that type of canvas in your digital work. And when you are doing digital work, you need to learn how to use resolutions. Resolution is basically just how many pixels your image is going to have. So you kind of want to understand what the maximum output that you're aiming for is. And generally a good practice is to draw in that output, if not twice the size of like the max output. And then you can just export your image smaller than what you need it to, because it's easier to export a large image to a smaller image than it is to export something from too small to too big. Because when you go from small to big, your program tries, unless it's a vector like Illustrator, the program tries to fill in little gaps of pixels, and then it looks really bad. But if you do by chance make too small and have to upsize it, as I have done on a project, you can find an online image resolution changer. So we've used Waifu2X. I've used it every now and then. Sometimes I'll find a different one. I don't remember which one I used because Waifu had a lot on its server at the moment. But so that's just in case you forgot to check your resolution and you need to be bigger, but I wouldn't rely on using that. It's good practice to just draw bigger and downscale it to whatever you need. On export. And then something for printing, it's not really like prevalent for digital. DPI. DPI is dots per inch. So it's how many, when you're printing, it'll be how many times the printer puts a little dot every inch. So 300 DPI is 300 dots per inch on the paper. And it's a lot of dots, but it also gets you a really clean print look. And this is important if you're going to be making art that for like banners or art books or merch. It's good practice to just kind of work in a 300 DPI canvas. Usually digital art, some people will be like the basic is 72, which you can do that. But as a failsafe, maybe you'll put it in a concept art book one day. You can just use standardly work at 300 DPI, and then you'll be like kind of future-proofing yourself. So that is resolutions. Moving on, we're going to talk about background assets themselves. When you're working with 2D backgrounds, you want to try to get in the habit of trying to plan everything in a layer, all of your assets into layers. That way, whenever you import them into a 2D game, like kind of like in the way that this Hollow Knight GIF is showing, you can create what's called a parallax. And that's an effect where stuff in the background moves by slower than stuff in the foreground. Or like the foreground's moving by faster than things in the background. It creates a sense of depth to your 2D worlds, and it looks nice. So you want to get in the habit of trying. I think you can even import Photoshop layers into Unity. You can import the files themselves. While I don't personally know how that looks, if you have your stuff layered inside the Photoshop file, it might import in that way as well. I haven't personally tested it, but I know it's an option that you can do. So usually if you like painting on one image, like one layer, that's totally fine. Just know that it like depending on what type of background you're gonna go for, it may be better to have it split up than it is on one flat images. And then when you are exporting, you finally finish your art and you want to get to exporting it. You want to export in either a PNG or a TGA. Never use the JPEGs. JPEG is not allowed in this house. Just don't come in here with it. It's bad. It's bad because it doesn't have transparency, and that's awful. You export something that's supposed to be on a transparent background, and it'll just have a white background, and it looks bad, and you can't use it. And it compresses itself way too much. It's good for like if you want to show something online and just as a presentation, but like it no. um, so PNG is good because it has the transparency, and then TGA is a little bit better. PNG is less compression than the PNG, so it's a higher quality, especially if you want to use like an alpha channel, which is good for textures. It keeps the alpha channel separate. Rather than the PNG, which has it just like baked into the image, so you can edit the alpha channel on a TGA. So that's really good for modeling textures, but just for exporting characters or like specific layers of a background, a PNG is pretty good in most situations. And then finally, something you should be aware of is something called a wireframe. A wireframe is just the flowchart of what you envision the game to look like. It's just a very rough with like however polished you want like idea of you go through what the options menu, you have UI, you have steps of how the characters interact, how the story progresses, and then you have like an asset chart of like, all right, you're gonna need this type of background, you're gonna need different boxes here, you're gonna need this tile sets for this level, etc. And it's a good way to kind of track and at least initially from as a concept artist or like a designer, if you're the creative director, trying to get the flow out for a game. And it's very helpful to give to your programmers too, because it helps to convey an idea of how the game's going to progress and like the scene wise of what it should look like, and it gets everybody on the same page, and you have a nice little reference of what you're talking about and where everything needs to go. So it's a good practice to start trying to work on developing those. That way it's a handy tool for the rest of your team. And then finally, we're going to talk about gray blocking, which is a common industry technique. These screenshots are from a game called Evolve. And it's kind of more, for the most part, I think gray blocking is usually done by game designers and the level artists, and they'll block out what the level is, and then they'll hand over a gray block image like this to the actual environment and concept artist, and you do a draw over of and concept art based on what the assets look like. So here you have like a basic factory, two basic factories, and then the artist goes in and draws a rendition over it, which eventually gets transported into a 3D model for that scene. So these are also really useful if you're gonna, for like laying out a big old level and you need to, you like doing an actual illustration really isn't going to be as helpful as having something that's drawn over the gray block of the level layout, because then you can put it into perspective, which is usually pretty difficult. But if you do the gray block, the 3D program is going to do all the perspective for you, so you kind of just have to follow the lines that have already been set up for you, so it makes that a lot easier. And perspective in these types of drawings, specifically when you're doing environment art or building design, is very important, because you're going to have to get all the modelers are going to have to get all the proportions and details correct. So it's just something to try to get used to. It's also a good workflow to try to experiment with. Like if you want to design a building or you want to design a level, you can try, or an illustration too. You can do a gray block and do some really basic modeling and then paint over that screenshot yourself if you have trouble with perspective. And then you get practice in 3D modeling, but then also you have a good base to draw over. So your final art and concept art looks really polished and clean, and you don't have to fight with all the perspective lines and details and planning out the composition. You can just move your camera in 3D space to get what you want. And so that's all I got for 2D. And this is a segue to move into good 3D art practices, which I believe Mitchell is going to talk about. Mitchell, do you want to take over the drive, or do you want me to drive?
I can drive. Give me a minute.
Okay. anybody has any questions, feel free.
All right.
I didn't see anybody, but thank you for all the questions.
All right. So first up is modeling efficiently saves time. So some basic things to do to model efficiently in 3D is, oh, hold on. You're going to want to basically use simpler shapes to combine to make more complicated models. So there's a concept in 2D, which I know Megan knows about, called construction modeling or construction drawing, where you can see there's images of his, and I think we did this on the 2D art workshop recently, where you have shapes that you'll kind of put together to give the general shape of an object by kind of combining, you have a circle here for the chest region, circle here for the head, some little circles for the feet, circle for the butt. You can see the hand here has all these different little circles and rectangles for the fingers and all the different joints. And that's similar to what you do in 3D modeling when you're doing something a bit more complex, is you have a lot of smaller pieces and shapes that are pretty simple. Like here we have some cubes, a semicircle. This is like a two-sided plane. And they all with very simple geometry here, and they putting them together results in this more complex model. Another thing that's helpful is working in low poly. So you will probably always need more or less triangles than you think, and that's commonly viewable in Blender as tris, or faces or vertices or whatever. And the lower poly you can get it, the faster it'll run and load in a game engine. And it's a lot easier to add geometry than it is to remove it later. So if you start out trying to basically model on a budget, and you deal with problems with that mindset, it'll be a lot easier to kind of deal with any problems in the future. And if you do want your high detail, you can always use normal maps and bake normals from a high poly mesh. So you could basically model something in like really high polygons, bake the normals onto a texture, which we'll get into in a minute here, and then use that normal map on a low poly model to sort of like fake the detail, essentially. And we'll get into how to do that in just a minute here. So modifiers are pretty rad. Here's a couple examples of some, but basically what modifiers are, they're like different specialized tools that you can use to modify all kinds of meshes and mesh data. So some pretty common ones that get used a lot and some pretty helpful ones that you can apply to a lot of different situations are these three. So the first is subdivision surface, which will subdivide each face on a mesh. So you can see here this each one face on this cube has been subdivided into 16 faces. And because each of them is subdivided into 16 faces and it's made a little bit smaller to smooth out, you get like this spherical shape. And that's one of the things that subdivision does, is it kind of tries to smooth out between all of the subdivisions it makes. So to make sure you get a like a rounded corner, right? You don't want the sphere, you just want the box corners to be more rounded. You have to add in all these extra edge loops so that it'll only smooth these two. It's smoothing and doing the subdivision smoothing along an edge on this part right here. And since this face and the center face are on the same plane of existence, like the same plane or whatever, you won't have any smoothing between those, which allows you to get this more flat face on the cube. Subdivision's really helpful, but yeah, there is a little bit that you have to learn about how it works before you can use it properly. Array is basically just a modifier for laying out objects. So here, this guy has made like a torus little donut, and then he has copies of the donut going down and getting smaller. In an array, this guy is a sort of frame of a cube. Oop. And it's being rotated and being made slightly smaller. And so it gives this kind of whirl effect. And this is just a box that's being copied and rotated around in a circle. And then the mirror modifier allows you to create more complex models by only doing half of them at a time. So you can create a symmetrical thing like a face or a car or a house or anything really, and only have to do half the model before you apply the mirror modifier. And then once you apply the mirror modifier, it will just copy over all the stuff that you've done on one side to the other side and make a perfectly symmetrical model. So they're pretty rad and super useful, and there's a lot more than just these three, and it's a good thing to learn those. References. So another important thing to do when modeling, and you'll see this when people are modeling a lot of like real world objects, is with modeling by reference. And this gets into a little bit of how what Megan was talking about earlier with the concept artists. Is usually in games you'll have concept artists come up with concepts for things. They'll draw a couple of perspectives of an object to give, you know, a character or an object or something. They'll hand that off to the 3D modeler, and then 3D modeler will set those images up in this sort of fashion here where you have top views, side views, front views. And then you can look at the object from all different perspectives, and then that'll help you line up your geometry for the 3D model to those images and create a 3D shape. Another thing that you can do to improve your speed and efficiency while modeling is learning your software's shortcuts. Blender, which is the main software that we recommend and that we use here at VGDC, has a metric ton of shortcuts. I think there's an infographic that's like, I forget what it is, but there's just so much stuff on it. Like if you actually had the poster hanging on your wall, you probably wouldn't be able to read it because there's just like everything's so fine. There's so many things on it. And then we have a link to our previous Blender workshop where we have some of the more useful shortcuts listed out. Staying organized to modelize. So when you're working in Blender, one thing, or any 3D modeling software, something that is helpful is keeping things organized. Oh boy, chat's blowing up, hold on. Okay, nothing super.
It's nothing important.
Nothing important, never mind. All right, so so sorting objects, making sure you're naming things. You'll see here in this bottom image, we have our scene collection. We have a tree, and that tree is made up of 3 different objects. Like I was saying earlier, you want to make things out of smaller things. So you have your tree leaves model, and those are your tree trunk, and then your tree twigs. Those are all kept together in the tree collection. So you can hide this whole collection if you're working on, say, the bush, and then you don't even have to see any of the trees, like it's invisible. So you can focus on like one thing at a time. And you can hide in Blender with the shortcut H. You select an object, hit H, and it'll hide that object. You can use Alt H to unhide objects, though that will unhide every hidden object at once. So it's a little bit of an annoyance. You can also hide objects by clicking on these little eye icons in the scene collection menu to not have to unhide or hide everything at once. It's also super important when you're trying to stay organized with the scene collection to have a naming scheme. So we have tree, and then we have the tree followed by the name of whatever part of the tree that it is. Alberto's given us a nice little template here. You have your base name, so tree, the disambiguation, so it's maybe a tree oak, and then the variation. So what number is this? The first oak that we've made? Is this the second oak that we've made? How many different variations do we have? How many copies? All right. So now once we've made our models, what we want to do is get them exported so we can move them into Unity or whatever other game engine we're using. So there's a little process that is helpful to make sure that whenever you do that, you come out with the least amount of issues possible. And we've listed that out here. So the first thing you want to do is check for excess geometry and overlapping vertices. So whenever you're extruding or doing certain modeling things, you'll make a mistake and extrude, and then not realize that you're extruding something, and then end up with an extra vertices, and they won't show up because they're basically like overlapping in the exact same space. And when you have thousands of vertices on a model, it can be really hard to pick out these extra ones that are basically in being like 2 right on top of each other to where you can't see. So an easy way to get rid of those is by going into edit mode, hitting A to select all the vertices, M to pull up the merge menu, select the option to merge by distance, and that will combine all of your overlapping vertices into just one vertice in each space where there are overlapping ones. Another thing that's important is backface culling. So you can turn that on here in the top right corner of the scene view. There's this little drop-down menu. You need to be in solid mode. Chat saying anything important?
Something about face orientation.
Okay. So in this little drop down menu, you need to be in solid mode. So make sure you have this just solid white sphere selected. Then you go into this drop down menu. You can select backface culling. And what that will do is it means that whenever you have a normal flipped inside out, which you can see down here with this cube. So these are the normals facing outwards, and it looks like a normal cube. And these are the normals facing inwards, where you can actually see through the back side of the normal to the inside. And the inside is where you'll have like it actually, you can't see through it. And that can be an issue because sometimes whenever you're scaling objects, if you scale negatively, it'll invert your normals. And you might not notice that you've done it unless you have backface culling turned on until you get it all the way into Unity. And then you have a weird looking model and it's all screwed up. So definitely a good thing to do to fix that. You just want to highlight everything in your model, just like we did with merging the vertices, and then hit Shift-N to recalculate your normals till they're all facing outwards. And the last thing that we're going to do is apply our transforms. So when you're scaling or moving around an object, you want to make sure that you have it set at the end to be, it'll basically inherit a bunch of rotations and locations about wherever you've moved stuff. At the end, you want to make sure that it's basically set to the origin. So it's at 0, 0, 0. Its scale is 1. So it's like 1 in the X direction, 1 in the Y direction, 1 in the Z direction. And it's rotated normal. It's at 0 rotation, so it doesn't have any wonky rotation. So that way, whenever you export it and you import it into Blender, or not into Blender, into Unity, you won't import like your character model or whatever laying face down while he's like the size of the Empire State Building, because you have a giant scale number and your rotations. To fix that, you would basically apply your transformations, move the model to the center, then he'll always pop up in the center of your scene in Unity, be the size that you would like him to be, or that's measured in Blender, which is found in the dimensions, not the scale. And then you can check that the origin and pivot is in the desired location. So you generally want, like, say, if you have a table or something, you want your origin for the table to be like towards the bottom of the table or bottom of the object, wherever you want like the center of gravity for said the object to be, because it's like the center of wherever things that interact with that object will rotate it about that axis usually. All right, so on to textures. Alberto, do you want me to cover this or do you want to take over?
Yeah, there is just one question in the chat about
sorry.
Applying the transform doesn't move the model to the origin.
Yes, applying your transform does not move your model to the origin. You need to move your model to the origin first and then apply transform. Because if you apply transform while it's not at the origin of the scene, or global 0, 0, 0, then you'll set wherever it is to be the normal, and then that's like even worse, because then when you import it into Unity, that'll be at 0, 0 location, and that's way worse. So yeah, make sure that you have it at global 0, 0, 0 when you're exporting. Thank you for asking that.
All right, so materials and textures to give good colors. Well, first and foremost, you got your diffuse and albedo maps, and this is the texture. When you talk about a material, you're talking about like all of these things combined, but technically speaking, all of these are images, and they're all individually just called textures. The texture is the image, the material is everything together. So the diffuse or albedo map contains all the color for whatever you're trying to texturize. You want to make sure it doesn't have any shading and that all the colors are at the same brightness level, because lighting is handled by the game engine. So whatever texture you have would have to be as bright as it could possibly be. Next would be the normal maps. And we talked about this earlier where we were talking about baking detail. So a normal map is essentially free detail because it's just a picture of a higher res version of the same thing you're trying to render. But what this means is you can have a totally flat surface, and a normal map defines how light will be calculated off of that surface. So the colors, it looks all rainbow-like, but the colors actually, for each pixel, the RGB values define the vector of which way that face is supposed to be pointing. So I don't know the exact numbers, but let's just say, for example, a perfectly blue pixel is pointing flat with the face. So if light hits it, it'll hit it flat. But then like a green pixel is like pointing to the right. So if a light hits it, it'll bounce the light to the right. And so the result of this is when you have a dynamic light, especially moving around the scene, it'll light the texture differently, and it'll look 3D because the 3D effect comes from the lighting. So you see in the image on the right, some of the rocks kind of have a glow on the right side, and then a blue glow on the right and the orange glow on the left, because that's how it would be lit if it was 3D. But that's just the shader doing that. The actual geometry of the cylinder did not change. So it's practically free detail. So use normal maps if your art style allows for it. And then the last one is displacement maps. That one's really fancy because it actually does deform your mesh. They're really expensive as a result because you need a lot of triangles for it to actually look good. And so modern game engines like Unreal Engine, they can do live tessellation of a mesh such that when you're up close to it, it'll dynamically create new triangles for that displacement map. And then when you're far away from it, it doesn't do that because you really only see it when you're up close. So on the right, you can see on the edge of the cylinder how the rocks kind of are actually bumpy versus the cylinder on the left, the sides are perfectly flat because there's no displacement on that. Another thing to kind of clear up here is a bump map and a normal map are the same thing. A bump map and a displacement map are the same thing. It's like, oh, well, that's kind of confusing, but that's because a bump map has height data, and you generate a normal map from a bump map because the computer can calculate what the normal is supposed to be on because you have the height information. And the displacement map is just literally the normal map, but actually creating height. Hopefully that makes sense. I don't see any questions, so, but yeah. The next part is UV unwrapping, smapping, and bapping. A 3D model that has a texture, well, you've got a 3D model and then textures are just 2D images. So how do you get a 2D image to go on to a 3D model? Well, it's good old-fashioned origami. And for real-world examples, you just got like look at the chocolate wrappers. You've got the Santa Claus there, but then when you like unfold the tinfoil, it's just a square with the like actual texture of Santa Claus there. Just fold it together around the chocolate to be the texture. And so this goes back to what Meghan was saying with the powers of two, because models, they don't require it, but it's really good practice just to use powers of two because they'll get, if you don't use a power of two, the texture will be stretched because when you export a UV map will be powers of two. That can be a little bit confusing, but if you just, it makes more sense when you practice it, like actually start making the textures and you're like, oh, that makes more sense. When you're actually going about modeling something that will eventually be unwrapped to be textured, do keep in mind where you put your seams because you cannot perfectly wrap a square into whatever 3D model you have. So like the example right there with the cube, you're always gonna have some blank space of how the texture fits onto the cube. And it's not, you can do your best, but it's not always going to perfectly wrap around the entire cube such that such that it's seamless. If you use something like Substance Painter, then the program will do its best to automatically paint over the seams, but you can hide the seams in places like an inside of a corner where it's going to be darkened by the ambient occlusion. So like on the armor there, all the seams are behind the armor or like on the edges of the armor, not on the front of the armor, because then you can't see it. And Yeah, you can do you can actually do texture painting within Blender. So that's pretty cool.
Yeah, and texture painting is when you basically have the UV or whatever, and instead of putting a texture, trying to like map a image to the model, you're basically just painting on the model, and then that will generate a texture from your UV.
And then last but not least, we got materials again, which are the shaders. So this just really takes a lot of playing around with, but it's a good idea to know what each part of a material is doing, just in general. So like in Blender, at least, you have the principled shader, which has plugin nodes for base color, subsurface color, normal, roughness, blah, 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 all this stuff. The base color is going to be your diffuse map. The roughness is actually a separate map, that's not a diffuse map, but the value, the roughness map is it's a grayscaled image because the values are going from black to white. And I don't know the exact value, but let's just say that a black pixel represents 100% roughness. And so when the light bounces off of it, it'll be absorbed because it gets caught in the roughness of the surface. And when the pixel is white, that represents 0% roughness. So when a light hits it, it'll bounce off completely and it'll be really shiny. So you can make a roughness map where it's a map of all the roughness values for that particular texture. So you could have the example that's often used is like rain and like a rainy rocky surface. So you can put roughness. You can vary the roughness to where maybe it's like some puddles show up within the little rocks, and like make the like the crevices between the rocks less rough. So then you can have light shimmering off of the rocks in a realistic manner. And this goes to the next point where you just color and light is very important because that's what materials are mimicking. So that's what the roughness map comes in. The specular map is similar to a roughness map, except it's more explicit in saying like this is shiny and this is not shiny, in the sense of using the reflections of the world. So the world's going to have reflections using cube maps, and so the specular map will tell each pixel whether or not how much of the cube map to use. So if you're making a mirror, it'd be like 100% specular because it'll reflect every single pixel on that thing will reflect. But if you're making like, again, like the puddles, you wouldn't want the rocks to reflect any of the cube map. So you'd make the water part, you'd make the parts that are supposed to be wet specular, but then the parts that are supposed to be dry, not specular. And like, it's not always gonna be perfectly black and white. You're gonna want to like make it a grayscale. And yeah, material nodes, that's just like all the material nodes available within the shader editor, and they're gonna be different for any program you used. But they're all kind of just the general same thing.
All right, and thank you guys for coming. But I have one more thing I would like to. I'm going to show off a little bit before we finish this off. I have a Blender project where I can show off a little bit of what we just talked about, so I can basically put it to practice for you all. So just give me 1 second here, and I'll get that up. All right, so here we go. Can everyone see this? Thumbs up, yes? All right, cool. So I currently work for the VR plants team at State, and this is what I do. I make plants in Blender. So here's an American elm, and this is sort of, I don't know, this just, my point here is I have all these plants here. I have an elm, I have a beet, that's loading in there. and I have a lily flower. The move zoom real quick. There we go. And all of these are in like their own collection. So that's, I have these sorted. That's something it's important. I haven't gone through and named the lily yet because that's the newest one that I've been working on. But yeah, so it is important to make sure that you have your scenes, your collections all labeled and organized, so you can find stuff easier and you can group things a lot easier, because all these models, since this is for a lab, so that people can basically dissect these. So I need to have every part of this flower basically be its own separate object that people can take out from the main, like the center. So that means I need to have all these as separate objects, and to keep them organized, I need to keep them in a collection. When I'm making this, I used this right here, this image, as a reference and as a texture for the petals, so that there's some modeling by reference. Let's see, just trying to see how much of this I can put to practice, because there's a lot of what we just went over basically goes into everything you'll do. There's a modifier that I used here. I used the array modifier to get these pistils all going around. And let's see, we did construction modeling, because these guys are literally just a cube right here, and then a cylinder for the stem part. I have some icospheres that are flattened right here at the end of this pistil. The stem is just a cylinder, and then I made the petals out of some circles. And then for materials, which is the other part of this, we can go into shading. And then you can see here how I have all this set up. So I have, this is my normal map, and this is my texture. And so you can get up close and see how this all works. So I can go and show you, if I increase the strength of this, you'll see the roughness of it gets, the detail kind of ramps up. So I think I had it about 1.5. But yeah, and you can, these parts here, these orange bits are just images. So this is the, you can see here, this is what this looks like. I can select this one here. This is the, what's the petal, I believe petal right there. So yeah, I cut this out in Photoshop and then made a texture for it. And then I have a flower. But yeah, point is, just goes to show how much of 3D modeling, you just knowing all the little pieces, not being particularly good at them or well practiced and expert in any field, but just understanding how all the pieces work together can really help you a lot when you're making things. I know this taught me, this particular modder basically taught me a lot about how this all works. But yeah, thank you.
Well, that reminds me, for the materials, you can save a lot of work. Let's say you have a rug material, or yeah, let's just like a rug material, but you want to have variations of it. So you want to have different colors. Instead of making 10 different texture images for each of the colors, you can just make one that's white and then use the material to add color to it. And then that's all, like you only have one image loaded in RAM, and then the computer handles the rest of the coloring. And also that's just less work for the artist to do, because then you just have to make one, and then that's it. You use that for all the colors you need.
Yeah, you'd use mix RGB in overlay mode to apply color to an image. That's grayscale. Because then what you can do is completely black image parts of the image turn out black, completely white parts turn out black, and then exactly halfway in the middle, gray images turn out exactly what the color is you're inputting. So in other words, you can think of the grayscale image as the luminosity value of the HSL slider of the other color.
So I think that's everything, guys. Thank you so much for coming, watching our workshop here today, and hopefully you all learned something. And yeah. Have a good week, guys. Thanks.
Next week we've got Ian Fraser's talk, and then